Hello friends, so this is part 5 for the year 2023, and here we are going to solve 3 questions. And all these 3 questions are from advanced. So in the first 4 part we solved the mains question, and this is the final part for the year 2023. In the first question, it states that in the circuit shown in the figure, the capacitor C is initially uncharged and the key K is open. In this condition, a current of 1 ampere flows through 1 ohm resistor. The key is closed at T is equal to T0. Which of the following statement is or are correct, given E inverse is 0.36. So basic figure is given to us. We are given that we have 3 parallel arms. So in arm number 1 we have resistance R in series with 15 volt supply, and we have 1 ohm which is in series with 5 volt, and we have a 3 ohm resistance in which current I1 is flowing, and a key is given initially which is open, and here we are having a capacitor of 2 microfarad in series with 3 ohm resistance, and it says that 1 ampere current flow 1 ohm resistance. So it means through here we are going to have a 1 ampere current. Okay. So we have to find out the these are the, it can be multi-correct. So first of all we'll try to find out what will be the value of the resistance R, okay, which is in the first arm. So let us assume that the current I is flowing through this R resistance, and we already know that our 1 ampere current is flowing. Let me name this. This is A, B, C, D, E, F, and this is G, and this is H. So current in arm AB, we say it is I ampere, and we are already given that current in DE arm is 1 ampere. So first of all, let's find out what is the value of resistance R. And for that we are going to consider the arm DC. So we can say for arm DC we are given that, so this is our D and this is our C, and the supply is our 5 volt and 1 ohm resistance is there, and it says that 1 ampere current flows through the circuit. Okay. So we are given here current is flowing through 1 ohm. Let us call this resistance our R1. So we can say voltage drop across R1 will be equal to our 1 multiplied by 1, which gives us 1 volt. And therefore we can find out the potential difference between our this D and C. Okay. And we are assumed that current, so this will be a positive and this will be negative. Okay. And we got that we have a 1 volt potential drop across this. Therefore we can say that the voltage at C will be equal to 5 plus 1, which gives us 6 volt. And voltage C, let us call this as VC. Voltage at C, we call this as VC, which will be equal to 5 plus 1. So from the figure, we can see our C, B, F and G all are at the same potential. So we found out our potential at C, which is our 6 volt. So therefore potential at B will be also 6, potential point F will be also equal to 6, as well as potential at G will be also equal to 6. Similarly, the other end means potential at A will be 0, D will be also 0 and E will be also 0, and this is when our key is our open. Okay, so to remember that this is all this discussion is for T is less than T naught, or we can say our key K is open. So we found out that the voltage at, you can say voltage at B, let us call that VB, will be equal to 6 volt. Okay. And so let us consider branch AB. So you can say for branch AB, and we can just so this is our A and this is our point B, and B is having a potential of VB, which is over 6 volt, and we assumed that the current through this is our I, and R is the resistance. Therefore we can write the equation that the current I this will be our positive and this will be our negative, and we are already given our 15 volt. Therefore we can write that 15 current I will be equal to 15 minus 6 divided by R, which gives us 9 upon R. And similarly we can use our branch EF, because the voltage at F which is our VF is equal to 6 volt. Therefore branch EF, so you can say for EF we can just, because there is no voltage source, so this is our E and we have F, and the current through here is our I1. This we already know is our 0, and F is having a potential of VF which is equal to 6 volt, and the value of resistance is given to us as 3. Therefore we can write that our I1 will be equal to 6 minus 0 divided by 3, which comes as 2 amperes. So therefore we have our I1 is equal to 2 ampere. So therefore option B is correct. Option B is correct. And so here we are having 2 ampere. So if we use, you can say, KCL, current law at junction C, we can say our I will be equal to 1 ampere plus 2 ampere. You can say using Kirchhoff's current law at C, and incoming current to C is our I. Let me draw it here. So this is our C junction. Incoming current is our I, and outgoing current here is our I1, and we just found out that the current to the other branch is about 2 ampere. And I1, sorry, it's not I1 but it's 1. This is 1. Therefore we can write that our I will be equal to 2 plus 1, which is our 3 ampere. Therefore we can use the equation. Let me write it here. I is equal to 9 upon R. Let us call this equation number 1. So from equation 1, we know our I is equal to 9 upon R, and I we just found out. So we can say our R is equal to 9 upon 3, which gives us R is equal to our 3 ohm. Therefore option A is also correct. Option A is correct. And next is, it says that at T is equal to T naught plus 7.2 microsecond, the current in the capacitor is 0.6 ampere. So basically here now the switch is closed. Okay. You can say that key is closed. So key is closed, and if key is closed, we are going to get a RC series circuit. So capacitor is going to charge through your resistance. Okay. So key is closed. Therefore we can call this circuit will be coming up like this. This is a capacitor, and we have a resistance of 3 ohm, and it is called as a HG. So this is H and this is a G, and this we know our VG is equal to 6 volts, and the value of the resistance is our 3 ohm. Capacitor is 2 microfarad, and now the circuit is complete because key is closed. Therefore we can say that for RC series circuit, initial current I naught will be equal to, we already know VG, and so this comes as our 6 divided by 3 coming as 2 amperes. So this is our I naught. And we can find out our time constant because it is going to charge for RC series circuit, or we can say charging. So we can find out our time constant, that is our tau is equal to R multiplied by C. So this comes as 3 multiplied by 2, which gives us 6 microsecond. We can write the equation for RC series circuit. So we can say current at time t is, suppose of I, that will be equal to I naught e raised to power minus t upon tau. And we can substitute value of t. So we get here our I naught is our 2 ampere e raised to power, and this comes as 7.2, and tau is our 6. So this comes as 2 e raised to power minus 1.2. And the value of e raised to power minus 1 is given to us. So we can say this current I will be approximately equal to 0.6 amperes. So option C is also correct. Option C is correct. And we have to find out at t is equal to infinity. So you can say at t tends to infinity, capacitor will be fully charged. Capacitor is fully charged to voltage, that is our 6 volts. So we can easily find out the charge. So Q is equal to C times V. C is about 2, and this comes as 12 microcoulomb. So therefore option D is also correct. Option D is correct. So in this particular question, all the options A, B and C are D, along with all the 4 options are correct. Next question. It states that a container has a base of 50 by 5 centimeter and height 50 centimeter as shown in the figure. It has 2 parallelly electrically conducting walls, each of area 50 by 50 centimeter. The remaining walls of the container are thin and non-conducting. The container is filled with a liquid of dielectric constant 3 at a uniform rate of 250 centimeter cube per second. What is the value of capacitance of the container after 10 seconds? Basic figure is given to us. We are given that we have a container and there are 550 by 50 and it is being filled by liquid which is having a dielectric constant of 3 and at a rate of 250 centimeter cube per second. Okay. We have to find out the capacitance after 10 seconds. So first of all, we are going to find out the amount of dielectric that will be within this container when time is equal to 10 seconds. So we can just use the basic mathematics, and we can say volume of the liquid after volume the liquid after 10 seconds. So we can say this as volume of the liquid will be equal to, it is volume rate is given as 250 multiplied by 10, which gives us 2500 centimeter cube. So we can find out the height of the liquid. Height of liquid, let us suppose this is the height and given by h. So height of the liquid will be where h is equal to volume, that is our 2500, and divided by its 50 into 5, which comes as 250, giving us 10 centimeters. So the height of the dielectric will be our 10 centimeters. Okay, so something like this. So from the figure itself we can see that now this container will be consisting of two different dielectrics. One will be our air and another, and that height we can just find out. H we found out is our 10, so this will be coming as 40. Okay. And this is having air as a dielectric, and H we found out is our 10. This is having a dielectric which is constant is given as 3. So we have two capacitors connected with each other. Okay. So we can just draw their equivalent figure. So this is suppose our capacitance having C1, and this is the other one in which we have a dielectric, and they both are connected with each other like this. Ideally they are connected through here, so we can just, for the sake of convenience, we just connect them externally. Let us call this as C2. Okay. And so let's find out the C1 and C2. So we can say our capacitance C1 will be equal to our, this be epsilon naught A upon D. Let us call this as A1 and this as D1. So we all know all the values. We can say our C1 will be equal to epsilon naught is our 9 into 10 to the power minus 12, and area we are going to get this as height is our 40, so this comes as 0.40, and our width is our multiply by 0.50, and D1 we just is our also 5 into 10 to the power minus 2. Okay, and from here we get the C1 will be equal to 0.36 10 to the power minus 10 farads. Now we can find out capacitance C2. Which will be equal to over K epsilon naught A2 divided by D2. We already know value of K. K is our 3, 9 into 10 to the power minus 12, and A2 will be our 0.10 multiplied by 0.50, and D2 is our 5 into 10 to the power minus 2. okay, because this width will be same, which is this one. And this gives us that value of C2 will be equal to 0.27 into 10 to the power minus 10 farads. Now we can just find out the equivalent capacitance. Equivalent capacitance C will be equal to C1 plus C2. Values are known to us, so we can say this will be over 0.36 and 0.27. 0.36 plus 0.27 into 10 to the power minus 10, and this comes as 63 into 10 to the power minus 12, which gives us 63 picofarad. So after 10 seconds it will be over 63 picofarad will be the capacitance. Next question. It states that an electric dipole is formed by two charges plus q and minus q located in xy plane at 0, 2 and 0, minus 2 millimeter respectively as shown in the figure. The electric potential at point P, its position given as 100 by 100, due to the dipole is V0. The charges plus q and minus q are then moved to point minus 1, 2 millimeter and 1, minus 2 millimeter respectively. What is the value of electric potential at P due to the new dipole? So here the position where electric potential is given and also to be found out is fixed. Only the position of the dipole is changed. Initially it is along our y-axis and then it is tilted in the different way. But important part is that here you can say origin, the point with respect it is rotated, that is origin is fixed. So we are going to solve this by using the, you can say, traditional approach, that of electric potential is K dot product of dipole multiplied by the distance and the distance square. Sorry, dipole moment, not dipole. And here from the figure we can easily see that, or we can say we are going to use an approximation that is called as a far field approximation. We can say electric potential due to a dipole, far field approximation. And electric potential due to dipole at a point which is distance of our r, and the formula is, you can say, standard, so we can say V is equal to 1 upon 4 pi epsilon naught. We have a dipole moment dot r position vector and divided by r square, and here P is the dipole moment which will be equal to q multiplied by the displacement vector or distance vector. Sorry, this is r unit vector, my mistake. R unit vector. Okay. This is the thing, but showing the direction. So initially, so you can say initial dipole calculation, initial dipole calculation, we are given that our q plus q is placed at 0, 2, minus q is placed at 0, minus 2. Therefore, we can find out our d1, and we can call this, for the sake of convenience, as a dipole vector. Dipole vector, and we can find out it as 0, 2 minus 0, minus 2, and this gives us 0, 4. Please remember these are in millimeter. So therefore, we can find out the dipole moment vector. Dipole moment vector, let us call this as P1, which will be equal to Q times D1, and we get this as Q multiplied by 0, 4, and we can write this as P1 will be equal to 0, 4 times Q. Later we can just solve this, you can say Q and everything. Now the observation point, or we can say the point where we need to find out this potential, is P, which is given 100 by 100. So we can say that observation point which is our P and is given as 100 by 100, and it is also in millimeter. So therefore, because it is with respect to origin, so we can say the position vector R, position vector R will be our 100 by 100 millimeter. We can easily find out its magnitude. So we can say magnitude R will be our vector R, its magnitude, giving us 100 square plus 100 square and its square root, which comes as 100 square root of 2 and in millimeters. We can also find out the unit vector because that will be required. So we can say R unit vector will be equal to, this comes as our 100, and inside we have a 100, 100, which gives us 1 upon square root of 2, 1, 1. So this is a unit vector. And then in the numerator we have a dot product of our dipole moment and the unit vector. So let's find that also, and we say dot product is our dipole moment P1 and our R unit vector. P1 we found out as 0, 4q, dot unit vector is square root of 2, 1, 1. And obviously this is representation of our x, and this is y, and this will be also x, and this is also y coordinate. Okay. And respectively it is I and j. Therefore we can say the dot product will be equal to 1 upon square root of 2, and this comes as 0 plus 4q, giving us 4 times q and square root of 2. Now we can easily find out the potential V0, because initially it says that the potential is V0. So you can say potential, which is our V0, will be equal to 1 upon 4 pi epsilon naught. We get this as P1 dot our R unit vector and divide by R square. We substitute the values. We get this as 1 upon 4 pi epsilon naught. Dot product is our 4q and square root, and we found out our R square is our 100 square root 2. 100 square root 2. And this gives us that the V0 will be equal to 1 upon 4 pi epsilon naught. So this will be our 4q, and this comes as 2 into 2 square, and this comes as our once again 100 square root 2, and this will be our 10 to the power 4, and this comes as our 2 square root 2 multiplied by 10 to the power 4. So this is our value of our V0 initially. Now we find out the new dipole configuration when the dipole is moved to another coordinate. So we can say new dipole configuration. Now we have our plus q is at -1, 2, and we have minus q is at 1 minus 2. And please remember, once again, they are in, everything is in millimeter. Therefore, we can say dipole vector, same calculation, dipole vector d2 will be equal to, this comes as our, we have here -1, 2, -1, -2, and this gives us -2, 4. Therefore, now we can find out the dipole moment. It was dipole moment. Yeah, dipole moment vector P2. Dipole moment vector, which is our P2, will be equal to q multiplied by d2, and this comes as -2q, 4q. Once again, we are going to find out the dot product. Because the origin is same, so our R unit vector is going to remain same. Dot product is our P2 dot our R unit vector. So this comes as -2q, 4q dot root 2, 1, 1. Therefore, we get that this dot product will be equal to 1 upon square root of 2, and this numerator will be coming as 2q. And we can find out the new potential. new potential, let us call this as V new, will be equal to 1 upon 4 pi epsilon naught, and this will be our P2 dot R unit vector and divided by R square, and we get this as V new is equal to 1 upon 4 epsilon naught. P dot R is our 2Q, and this comes as our square root of 2. R is our 100 square root of 2 whole square, which gives us 1 upon 4 pi epsilon naught, and we have this as 2Q. This comes as 2 root 2 into 10 to the power 4. And now we can just simply find out the ratio. That is our ratio V new upon V naught, and this comes as 1 upon 4 pi epsilon naught 2Q divided by 2 square root 2 into 10 to the power 4, and it comes as 1 upon 4 pi epsilon naught, this is our 4Q, 2 root 2 into 10 to the power 4, and all the terms are going to cancel with each other, and this goes by 2. So this will be equal to 1 by 2, or we can say new potential V new will be equal to V naught by 2. Yes, is V naught by 2. That is option B is correct. Option B is correct. This question can be also solved by using the cosine of the angle, which is also one of the way. Okay, so we need to find out this angle, and when it is rotated, we are going to find out this angle, and accordingly we can just solve it. But in the end, we are going to get the same answer. So this method is more of a traditional way, but we get the answer correctly. So these were the 3 questions from the year 2023. All the 3 questions were from the advanced, and thus we completed all the questions from the mains as well as advanced from the year 2023. It took close to 5. It was divided into 5 parts. First 4 parts were only about the mains questions, and this 5th part we dealt with our advanced questions. So this completes all the questions from the year 2023 mains as well as advanced. Thank you.